Hello.
Hi. Is this a question class or is it a regular class?
Oh, it's kind of both.
Okay.
Well, I always like to. Well, I like to make the assumption that people have done stuff before they come here to the Zoom session, but I think the reality is that they don't. So I do tend to go over everything anyway.
Yeah, I tried to make it a point to do that this time.
But I don't know. I just want to make myself available is all.
Okay. Nah, because this week, most of our classes are canceled, so I was just making sure.
Most of your classes were cancelled. Oh, okay. Well, I don't know about that.
Well, not canceled. Yeah, they're like, you don't have to show up this week. If you have questions, just come, but just try to get the assignments done.
Fair enough.
I guess people are catching up on grades. Or...
Okay, let's see. All right. Let's share screen. Okay. All right, so we'll get started. We're having the mole discussion today. Now, next week, I'm going to send an email out about this, but I'm not going to. Let me put on some light here. I look like I'm in the dark. I won't. There won't be a Zoom session next week. I know there's one scheduled, but I'm going to send out an email, so there won't be. I'll be traveling that day, so I won't be able to do it. But at the same time, Module 8 is one of the easier modules, and if anybody has any trouble with it, all you need to do is send me an email or call me. My phone number's in the syllabus. I don't really get too many phone calls from people, but if you need the help, then you can always call me. All right, so we're going to start out.
Bro, but yeah, Gunny Brewery's good.
Okay, so we're going to start out.
I feel like everything that has any kind of live music has been that. I was looking for like a.
So let's take a look at what we're dealing with the mole situation. First of all, what is a mole? Well, a mole in and of itself is 6.022 times 10 to the 23 particles. And for a compound, that means molecules. And for an element, particles are atoms. So I think that's important. But 1 mole also happens to equal the molecular weight of anything in grams and 22.414 litres of any gas at STP. Do you have to memorize all those numbers? No, because if you look in the problems that I give you, both in the homework and on the test, I give you those equivalencies. So everything we do is going to be based on that, and in some ways it's going to be easier than what you were dealing with in Module 3 even, because there were so many more conversions for you to look at. Here, there's just these 4 equivalencies, and every problem we solve can, at least in most part, be solved using these equivalencies. There's one other equivalency we can talk about, and that is the number of atoms in 1 molecule. So what I'm talking about there, for example, would be if you had ALF3, there are 3 F atoms, or 3 atoms of F in one molecule of ALF3. So that's what's important, is these equivalencies, these things that equal each other. If you want more good guidance about this or a little bit more background, you can read what's in the soft chalk. The first thing we need to be able to do is figure out a molecular weight. So I think that that's something that usually people don't have that much trouble with. So if you had Al2SO33, it'd be a matter of just counting up all the ions. Sometimes it's good to draw out a picture, and that's what I've done here. 2 aluminums, 3 sulfurs, 9 oxygens, and just adding all those together and then coming up with the total. Now, as far as significant figures go, it's going to be based upon how many places past the decimal you have. And that's going to vary depending on the periodic table you're using. Some periodic tables just go to 2 decimal places. Other periodic tables go to many more decimal places than that. Technically speaking, any compound you come up with goes with the smallest number of places past the decimal of all the atoms that you're dealing with. But in this instance, I've chosen a periodic table that only goes to 2 decimal places, so the answer comes out to 2 decimal places. Does anybody have any questions about finding molecular weights?
No.
The other thing that's important to note is that every periodic table we experience is a little bit different. Every periodic table has slightly different masses for the atomic masses and and therefore for molecular weights. The reasoning for that has to do with when the periodic table came into being, well, the particular periodic table we're dealing with. And that's going to depend upon the data that people have for natural abundances of different elements in their isotopes. So because there's slightly varying data on all of that out there in the world, then there's also going to be slightly varying data on different periodic tables. So it's very important to make sure that if you're finding molecular weights and I'm telling you you have to use a specific periodic table, then you have to use that periodic table. The other thing we can find molecular weights of is hydrates. Now, a hydrate is like what I have here, CuSO4 dot 5H2O. The dot here doesn't mean multiplication. What it indicates is that it's CuSO4 with 5 waters of crystallization around it. So in order to get the molecular weight of something like this, it's going to be copper and then sulfate, SnO4, and then 5 molecules of water. And each water is going to weigh 18.02 grams. So that's how we can come up with the molecular weight of the hydrate. Does anybody have any questions? Again, if I'm telling you...
Can you repeat that last one?
Sorry?
Can you repeat the last one? It's
yeah, so it's going to be...
How do you get them?
So it's going to be 1 Cu, 1 S, 4 Os for the CuSO4, and then add 5 molecules of water, and each water weighs 18.02 grams.
Gotcha.
Okay. Now let's take a look at 3 molecules of P2O5. Now, I know this seems kind of trivial, and you could probably do it in your head without using dimensional analysis, but I'm trying to train you to solve these problems using the same techniques as we used back in Module 3. So the idea is I always like to write out what we're starting with, then I draw a line, and on the bottom I always put the unit that we have on the top. Now I don't put number next to it, I just put the unit. So it'd be molecules of P2O5. Now the unit also includes the compound here as well. So it's 3 molecules P2O5. I know molecules P2O5 has to go on the bottom. Then on the top, we've got atoms of oxygen. So I'm looking for some sort of relationship there between atoms of oxygen and molecules of P2O5 that's an equality relationship. And that's what we have here. The number of atoms in one molecule, or it equals one molecule. So it'd be 5 atoms and 1 molecule. So you'll notice the technique I use here. I always put the units in first and then I put the numbers in at the end. The other thing I make sure of is that whatever's on top and whatever's on the bottom equal each other or have some sort of equality relationship between them. The answer then comes out to be 15 atoms of O, since everything else cancels out. Anybody have any questions? All right, this one is a little bit more difficult. We're going to go from moles to atoms in this instance. So let's have a look at how we might handle that. We're looking for the number of F atoms in 5.0 moles of AlF3. So that's what we're starting with. In this module, it's very easy to tell what you're starting with because it's going to be whatever has a number in front of it. Just remember to include both the compound and the unit moles of AlF3 when writing this down. Times and a line, so moles of AlF3 goes on the bottom. Now what we're looking for is atoms of F, but unfortunately there's no relationship that allows me to go straight from atoms of F to moles. I can go from atoms of F to molecules, but I can't go straight to moles. So that means I'm going to need another step here. So I know that at the end I need atoms of F. So I'm going to put that up the top here on the second step. Now I need to figure out what unit is going to link these together. Now you can see here from this equality relationship that number of atoms is equal to 1 molecule. So I know molecules is what's going to be required here. So we need molecules, and molecules on the bottom. But molecules of what? It'll be molecules of, in this case, AlF3. And molecules of AlF3. Now then, since we've got the units here, we can go ahead and put the numbers in. And per what I've got up here, 6.022 times 10 to the 23. Now this is a molecule, it's a compound, not an element. So 6.022 times 10 to the 23, and that equals 1 mole. And there's 3 atoms of fluorine for every 1 molecule of AlF3. And from there, that gives us our answer, which comes out to be 9.0 times 10 to the 24. All right, this is a good time for me to make sure that you're entering stuff into your calculator correctly. So what I want you to do is I want you to try putting in those numbers into your calculator and making sure you're getting the right thing. Now, when you're entering the exponent, you'll enter the 6.022 times 10 to the 23 as follows. Now, it's going to depend on your calculator a bit, but it'll be 6.022, and then on your calculator, you'll have an EE button, or it's possible that you might have an EXP button. So either one of those, and then 23, that's what you'll do. So could you please go ahead and make sure that you can do that on your calculator. And if anybody's having trouble, let me know and we'll talk about it.
Good.
You're doing 5 times 6.022 times 10 to the 23 times 3, you should come out to 9.0 times 10 to the 24th, or 9.0 E24 is what it will be 9.0 something, 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 but it'll be shortened down to 2 significant figures because that's what we started with. I'm going to mute them. There we go. Anybody have any questions about putting this in your calculator? I can't stress enough the importance of doing that, making sure that you use the EXP or EE button. There are certain problems that we're going to do later where if you don't do that, I know you're going to end up with the wrong answer.
I had trouble with the calculator part.
And what kind of calculator you got, Alex?
A TI-30X IIS.
Okay.
Yeah.
Did you find the EE button or the EXP button on that calculator? I don't know if that calculator actually has one. I'm not a real fan of that particular calculator. My favorite is the TI-30XA. I love that calculator. If that calculator was a girl, I'd marry it. But I'm not a real fan of that calculator you've got there. It's hard to enter those exponents properly into that calculator.
Yeah, I got 9.033 times 10 to the power 24.
Well, that's the answer. That's what you should have gotten.
9.033?
Yeah, but it gets shortened down to 9.0 because of the sig figs. So we start with 2 sig figs, we end up with 2 sig figs in the
Where
end.
did you get the 2 sig figs from again?
If you look at the 5.0 at the beginning, that has 2 sig figs, right?
Uh-huh.
So your answer is going to have 2 sig figs as well.
So the first number you start with, the number of sig figs and the first number you start with is going to be your answer?
That's how many you're going to have in your answer. That's correct. The reason for that is because 6.022, that has 4 sig figs. The 1, the 3, and the 1 here in the working are all counting numbers, so they don't count for sig figs. So all that's left is the 2 sig figs you have at the beginning, and that's what's going to define how many sig figs you have in your answer.
Oh, okay. I'm sorry. I didn't.
You're
Thank
right?
you.
Okay. Well, the rest of these are actually fairly easy problems.
Yeah, it seems like just setting them up and then running through them.
Right. But I'm going to do some more examples here, and then we're going to look at the homework, and then we're going to look at the kinds of problems you're going to see on the test as well, okay? So we're not done yet. So let's say you're looking for how many grams of P2O5 are in 3.10 moles of P2O5. Okay, so 3.10 moles of P2O5, that's what we're starting with. Yeah, look at the pad and look at the way I set it up. Moles of P2O5 go on the bottom, and then I figure out what I want. What do I want? I want grams of P2O5. I actually can get from moles to grams according to what I've got up here. So I know that grams of P2O5 is what I'm looking for. The relationship between them, apparently 1 mole is equal to the molecular weight. So the molecular weight, we actually, well, on any test, I actually calculate the molecular weight for you. So you don't even have to do that. So it'd be 141.2 or 0.94 grams, and that's 1 mole. And that gives you, that'll give you your answer. So that would be, in this instance, 440 dot. That'd be 3 significant figures. Sorry. Anybody have any questions? So we can also do the reverse of that as well, of course. where we can find the number of moles of, say, ZNO if we start out with grams. So grams of ZNO is what we're starting with. We do times and a line. We put grams of ZNO on the bottom to cancel. And we're looking for, well, moles. So moles go on top. And then I look for a relationship, and it looks like 1 mole and molecular weight. And 1 mole is equal to 81.36 grams. And then we end up with 2 significant figures as our answer. And that would be 0.061 moles. Remember that leading zeros are never significant. And that's all there is to it. If you follow the method that I'm using, I just don't see how you can go too far wrong with this. Any questions? All right, let's take a look at something where we're going to use liters. How many liters of O3 gas are in 5.00 moles of O3 gas? So moles of O3 go on the bottom, liters of O3 go on top. What's the relationship? According to what I've got up here, 1 mole is equal to 22.414 liters. You do have to memorize that? No, I'll give you out every time. And then you come up with the answer, which in this case has 3 significant figures, 112 liters of O3. Anybody got any questions? I'm going to skip over the next one. It's pretty much the same thing, just in reverse. Let's look at number 8. This one's interesting. Now this one could be done in 1 step or 2 steps, but I'm going to do it in 1 step because it's a bit easier that way, I think. But we're starting out at 60.9 liters of O2 and we're trying to go to grams. So I know liters of O2 goes on the bottom. And I actually have a relationship that allows me to go from liters of O2 to grams. And that is if we put 22.414 liters on the bottom here, that equals the molecular weight, which is 32.00 grams. Now, how did I do that? Well, the thing is, if 1 mole equals all of these different things, then molecular weight is also going to equal the molar volume of gas at STP, which is 22.414 liters of gas at STP. So those 2 things will equal each other as well, which allows us to do it in just 1 step.
So they'll cancel out, right? Since they're both 1.
Well, I mean, the 1 moles would cancel
I mean, like,
out. Yeah, if you had, you see, take a look over here at the soft chalk. If you look at this top example here, let me enlarge this a bit. There we go. You see how there's 1 mole and 1 mole? So you could do it in 2 steps if you wanted to, or you could do it the way I just did it and just do it in 1 step because the 1 moles are going to be the same.
Okay, got you.
Now on any homework or test, you'll know how many steps to do because I'll tell you. But if I'm asking you to do it in 1 step, then you'll have to assume that there must be some relationship that allows you to do that. All right, any other questions about this one? Okay. All right, next one, atoms to grams. So let's say we have 1 atom of Fe. How can we find out the number of grams? So we start out with 1 atom of Fe times, and we've got a line. Now we know atoms of Fe is going to go on the bottom. And we're looking for grams. Now we do actually have a relationship that allows us to go from atoms of Fe to grams of Fe. Since we're dealing with an element, then we can see that we can use our atoms up here, and we know that 6.022 times 10 to the 23 atoms, and the number of grams would be the molecular weight or the atomic weight of iron, which I think is 55.85 grams. So this one, yeah, is especially important to make sure that you put this into the calculator properly. The answer we come out with here, and there's a couple of things to talk about here, especially with significant figures too, 9.274 times 10 to the negative 23 grams. Now that's a pretty small number, but remember we are talking about the mass of one atom here, and I'm not expecting a very large number for that answer. Does anybody have any questions so far? I'd really like you to put that into your calculator, please, and make sure you are coming out with the same answer as what I came out with. Be certain to use that EE or EXP button. If you don't use it, you'll know because you won't get the same answer as me. You'll get something like 10 to the 24, 10 to the positive 24 as your answer, and that won't be right. So I'll give you a minute or so here to plug that into your calculator, making sure you are getting that answer.
I got the answer, but I was wondering what number is going to tell us how many sig figs is going to.
Oh, okay. You see how the one here is a counting number. You can't have half an atom, so that's a counting number. That's not going to define your sig figs in this case.
Mm-hmm.
It's going to be defined by what you have over here. You have got the atomic weight, which is 4 in this case, and then the Avogadro's number, which is 4 as well. So the answer comes out to be 4.
Oh, okay.
Now, this is a bit of an anomaly. I mean, generally speaking, we get the number of sig figs in the answers the same as what we start with. But in this case, we're starting with the 1, which isn't defined by sig figs. So we have to look everywhere else to find the sig figs here.
Oh, okay. Thank you.
It's not what we usually do, but it is for this one. All right, any other questions or anybody having trouble getting that answer in their calculator? Okay. The other one's pretty much the same. All right, this last one is probably the most difficult problem that you'll have to face here. But again, it's not as bad as all that either. So what we're looking for here is the number of atoms of sulfur in 51.0 grams of Al2S3. So we're expecting a pretty big number here if we're talking about the number of atoms. But we are starting out with 51.0 grams of Al2S3. And we are going to have to do this in 2 steps because there's no relationship that allows us to go straight from atoms of sulfur, straight from grams of Al2S3 to atoms of sulfur. We're going to have to include molecules in the mix along the way. So we know that grams of Al2S3 go on the bottom here to cancel. We also know we need atoms of sulfur. And the linking unit that we're going to use will be molecules. So molecules of Al2S3 will go up here. And it will also go down on the bottom of the second part. So molecules of Al2S3 will go down here as well. The relationship between molecules and grams, 6.022 times 10 to the 23. grams of Al2S3. Well, that's going to be the molecular weight, which is 150.17. Again, you'll be given the molecular weights, you won't have to calculate them. And then it's going to be 3 atoms of sulfur for every 1 molecule of Al2S3. So let me give you another tip here to enter this into your calculator. This is how I would do it. I would put 51.0 times 6.022 EE 23 times 3 and then divided by 150.17. Just do it as one single operation, then come out with an answer that's going to have 3 significant figures, and that would be 6.14 times 10 to the 23.
It's a lot easier.
Yeah. So the tip I'm telling you here is multiply everything that's on the top and divide anything that's on the bottom. And if you do that, you should be all right. All right, I'd like you to enter that into your calculator, please. Make sure you are getting the same answer as what I'm getting. Does anybody have any questions? Okay. Well, that's pretty much it for that. Let me go through some of the other things that you'll need to be able to do. We'll start out with the Module 7 assignment. Now, I want you to remember that there's a video for every single one of these assignment problems. It's in the Module 7 video tutorials folder. There's also a tutorial there on how to complete D2L matching exercises, so make sure you understand that as well. Let's take a look at it. Hopefully, I mean, my hope is that people have already done it, but I don't know. So here's an example I'll show you for this one here. I'm going to move this over to the edge if I can. If it'll let me. There we go. So it's asking for the number of carbon atoms in C12H22O11. So we know that molecules needs to go on the bottom and atoms of C needs to go on top. Specifically, it's going to be 12 atoms per 1 molecule. So I know it's going to be 12 atoms for number 1, and then 1 molecule for this one would be number 2, and everything else is going to be number 3, and you do need to put the 3s in. Even though we don't use the answer, we still have to put it in as the unused answer. Otherwise, it will mark it incorrect. That's what that video talks about, is making sure you do that. And that's pretty much what all the problems are for the assignment are like for that. Anybody have any questions?
No, it's pretty good.
Let's look at the practice quiz. Remember, you get to do the practice quiz as often as you want. You need 80% on it though to get to the credit quiz. If you're really concerned about wanting to know what the formatting is, before you actually do it, then you have the option of just not entering anything in at all and just going ahead and submitting the quiz. It'll tell you the answers. The answers will be in parentheses. You don't include the parentheses at the end, in the beginning. You just include the answers. And that will tell you exactly what kind of formatting I'm looking for. And then, some people get frustrated because, they start doing it and they miss out on spaces and that kind of thing. And then they get all frustrated because they didn't know what the formatting was being looked for. And now, if you do this, then you'll know straight away. You won't have to worry about that. Some people don't mind doing that, but some people get frustrated, and I don't want that to happen. Does anybody have any questions about doing the practice quiz here? You'll notice it says you must use the periodic chart in this folder. So that's the periodic chart in the Module 7 folder, and take the answer to 2 decimal places. Don't use another periodic chart, otherwise you will get a different answer to what I came up with and it will be marked wrong. Does anybody have any questions? So the credit quiz is going to have exactly the same format as the practice quiz. All right, let me talk a little bit about the kinds of problems you'll see on test 3 that relate to this module. So this is practice test 3 that I'm pointing at now. Remember, test 3 has exactly the same format. Now, what I recommend you do is when you're doing this test, because you have to use this on-a-lot calculator, is open this in a new window. So open on-a-lot calculator in a new window, and you see it opens there. And I want to show you this because I want to show you how to enter. I want to show you how to enter exponents. So I'll clear that out. Let's see. All right, let's do this as an example here. So 1 atom of Na, I know that it's going to be molecular weight. The molecular weight's in the problem here. I was telling you about this earlier. See, it's right here. So it's going to be effectively 22.99. Sorry. Let's clear that out again. Try it again. 22.99. And then it's divided by 6.022 times 10 to the 23. So I want to show you how that gets entered into the on-a-lot calculator. So 6.022, there's your EE button here. Notice it goes a dark gray color. That tells you it's active. You hit into 23, and then you hit equals, and it'll bring you to the right answer. All right, does anybody have any questions? So I guess I want to make sure that that's what people do. They practice with the on-a-lot calculator, because you can't use your calculator on the test, so you may as well practice with this one. Now I put a link to it here in this practice test. On the real test, there's a box you click and it brings up the calculator. All right, does anybody have any questions? That's pretty much all I had wanted to go through today. Does anybody have any Module 7 questions they want to talk about? All right, just a reminder, there won't be a Zoom session next week. I know one's scheduled. If you need my help, email me, call me. And I mean, I'll still be answering calls. I just won't be having a Zoom session next week. Thankfully though, Module 8 is not that difficult. I think you'll be okay with it. All right, there's something in the chat here. I just want to make sure. Okay, the 60.9 litre question again. Okay. Let's go take a look at that.
Hey, Professor,
Yes.
I got dropped right when you were entering the exponent in the calculator. Are you going over one of those again?
Oh, I'll do it again if you like.
I just need to
Gwen?
know, like, just to make sure I understood, like,
Yeah, okay.
just put the EE and then I
Right.
think I understand, but just want to watch.
Okay, Gwen, hold on for a second. I will go over that problem you asked me about, okay? So 22.99, then divided by 6.022, and then EE, it goes grey and hit 23, and then hit equals,
Got it.
okay?
Yeah, that's what I thought. Okay, thank you.
Okay. All right, Gwen, I'm going to hunt down that question you're asking about. No. Oh, this one here, right? Okay. 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 Let's get that going. Need to. Okay. So if you've got, we're starting out with 60.9 litres of O2. And we can do this one step. We can do litres of O2 goes on the bottom to cancel. And we do have a relationship that allows us to link grams of O2 to litres of O2. And that's what we're doing over here. You can see we've got the 22.414 litres and we have the molecular weight in grams. So those two things we actually have an equality relationship between. So the molecular weight is 32.00 and the litres in 1 mole is 22.414 litres. And then that gives us our answer, which comes out to be, in this case, 86.9 grams of O2. Is that fair enough, Gwen? Okay. Does anybody else have any other questions that they want to ask about Module 7? How am I getting the 86.9? Okay. So in your calculator, you'll put 60.9 times 32.00 divided by 22.414. So multiply everything on the top, divide everything on the bottom. That should give you your answer. This has got 3 sig figs, so your answer comes out to be 3 sig figs as well. Okay. So that's something good for you to practice, Gwen. When you're trying to solve these problems. If you're continually having difficulty, set up an appointment with me, and we'll go over your specific calculator. Also, the on-a-lot calculator if you need to do that. All right. Any other questions about Module 7? All right. Well, I guess we'll leave it there then. If anybody wants to hang around and ask me anything, they're more than welcome to. I'll stay for a couple of minutes, make sure everybody's up to speed. Okay. All right. For the rest of you, see you all later.
All right. Thank you, Professor. Have a good one.
No worries. You too.
Thank you.
You're welcome. No problem.